The weld symbol. Some of this is fairly review, or should be review, I hope. Setting up parts, making sure you know, and you've seen this picture before is in the shop. It's the proper setup of the joint. When we say, a lot of times on the T-joint, the T-joints and the laps are the two that you don't really think of it in position, or 1G. Most of the time, we think of this, if this is a T-weld, we think of this being in the flat, and that's actually in the horizontal position. A flat position on that would be something like this, where it's in almost into the V. Okay? So when you get to this test, and there's some on there that you will see that you will do, and set them up like that, because you will see a lot of those welds in that V. You will find that it is not hard, it's actually way easier, as long as that V is opened up enough where your nozzle can get in there. So, when you're making a joint, or preparing a joint, you as a welder probably are not going to have to prepare a joint like this unless you are working in a small shop situation. Who is going to prepare the joint for you to weld up? If you're working at Henderson, how are those joints going to become prepared? From the fab, from lasing. They're going to be done before they get to you. On the print, when you see the print, it's going to show you what that weld has to be, or what that joint will be due to the symbol. But you will not have to prepare that joint necessarily. Now, with that being said, if something gets missed and it's asking for a V groove, and it came into a square to you, probably a pretty good thing that you make sure you catch that and either send it back to fab or talk to somebody and say, hey, should we groove this out to make sure that it's done right? Okay? But on your joints, your basic joints, you've got your square. Square groove would only be used on thin material. Okay? Gap is always what? If I've got a square groove, what am I going to gap my two butt joints, or my butt joint at? It's kind of the rule of thumb. Half the thickness. Okay? Always remember that, half the thickness. You've got a bevel. Bevel is on one piece. Double bevels, one piece, both sides. V, basically it's a bevel on two pieces. Don't get screwed up with that. Double V, both sides. J, kind of an arced out. To be honest with you, I've never seen one. I'm not saying that they're not there. You got to remember, when these symbols are written, they're written for every weld situation known to humans. Okay? Double J, U, W, a flare, where a piece is bent and a piece butts up to it. That'd be a flare bevel. A lot of times, too, a flare bevel can be practiced like this, when you got a rod. See, yeah, and the piece welded like this. Okay? That's going to give you that bevel. Flare V, okay, two pieces bent, or two rods, same thing. And then an edge weld on the flanged butt. If a piece is flanged, that flange is on the opposite side of the bend, and that's where your edge weld. And that's probably when you do an edge weld. We probably haven't done a lot of edge welds. We don't do too many of them. Try a couple, but they're not super used quite, often. They're not used a whole lot. But with an edge weld, you just make sure that you're penetrating to each side. Okay? Like a corner, very similar. There is a welding symbol. Everything on that symbol at some point would be used in a part. Okay? All of those letters have meaning, and that's where they are at all times. So as you look at this, you'll become familiar, and you'll start to notice, similarities. When I want to know what the finish symbol is, that's grinding it, machining the weld, chipping the weld, things like that. There'll be a letter here. It wouldn't be an F. It'd be, let's say, if it's going to ground. It's a corner, and it needs to be ground sharp. It would have a little G there. Okay. Length of weld, pitch of weld. We haven't talked a lot about that. We'll talk about that. Skipping welds, intermittent welds. Okay. You'll see a lot of intermittent welds when strength is not necessarily a concern. The part's got a hole. part's got a hold, but it doesn't have the strength value that, you know, it's just there more for aesthetic purposes, just to make sure things are all held in place. Joint weldment shows how the edges are to be prepared. Just like I said, it'll tell you what the preparation needs to be, what the joint needs to look like. This is where it kind of gets cluttered, okay? When you start putting weld symbols into a print, especially an industry print, things can really start to get cluttered up. The weld symbol can go on any view. The welding symbol can go on any view of the part. The best view suited. They stick them in wherever they can. Okay? So the first parts we're going to talk about are the reference line, the arrowhead, and the tail. Your reference line, when done correctly, will always be horizontal. Okay? That line will always stay horizontal. Now the the arrowhead can go any way. It can go this 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 way. You know, it'll have an arrow to it, and that's going to tell you what joint it's going to. The last part is the tail. The tail is used for any special specification that you need to know as the welder in order to complete that product. A lot of times you might see in there a TYP. Anybody know what a TYP means? Typical, which means any joint that looks that way is welded that way. You might see something that says note. Note 1, note 15, okay? And then you'll follow back and you'll find where the notes are on that print, and that'll tell you what there is to do there. There are your weld symbols. Welding symbol is different than a weld symbol. The welding symbol is everything. The weld symbol is specific to what you do on that particular, what you weld you put on that joint. So some of your common ones, your V, maybe a bevel, flares. This one is by far the most typical. That's a fillet. T-weld, lap weld, things like that. You'll see squares, okay? Plug, you might see a plug weld. Spot surfaces, stuff like that, backer backing, a lot of that you probably won't see. You will definitely see that. Weld all around. Welding on pipe, welding on square tubing. Some of these guys who weld all the way around, they can, instead of making that arrowhead all the way around, they can just circle that, and that tells you just keep going. Field weld, not very often. Flush. And this chart, I know it's hard to see, this is also in that packet. There's no order to it, but it's also in that packet. So you can see a little bit bigger. Plus it's on the back of that little card that I gave you. Okay? So here's where the fun starts to begin. On the drawing of a welded part, the arrow of the welding symbol touches the line to be welded. Okay? If I've got, now you would see a much more complicated than this. That is the side to be welded. Okay? The side of the metal which the arrow touches is known as the arrow side. Pretty simple, right? The opposite side is known as the other side. When I get ready to draw my symbol or have my symbol read, when the weld symbol is below the reference line, it is welded on the arrow side. Below is arrow. Above is other. Now you ask, why the heck do they do that? Just to make it complicated? Remember how I said some of those prints are very involved? Sometimes they can't get it above or below, or they can't get to that joint the right side. So they'll put it on one side or the other to kind of help you out. Now obviously if you see something like this, It's on both sides. Okay? Pretty simple. Below, arrow. Above, other. Both sides, you weld both sides. Alright, so that's with the fillet weld, that's with the groove weld, anything like that. Now let's look at a groove weld. So I have a piece here. Looks just like this. Man, I need a better marker. Can you guys see that marker at all or not really? You see it alright? So my arrow goes here. Sits here, goes like this, right? Below this, 1/8 of an inch, 60. That's telling me the root opening is 1/8 of an inch. The angle is 60 on that V, or 30 on each side. Now, as I said, you're going to be getting these parts to you, so hopefully that the angle was already cut. You just have to make sure you gap it correctly. Now, why would you have to gap it? I mean, I know it says that, but what would be the purpose of them making you gap it? Strength. That's all figured out. The mathematical sequences and stuff that engineers do, that's figured out. That's where the piece has to be to make sure the joint penetration is there so you can have the strength that's needed for that part. Okay? So that 1/8 of an inch is important. Alright? Now, next part. So everybody's got that. Below the reference line, arrow or other? Arrow. Below is arrow. Above, other. Huh? Both is both. It's not A and A. How about that? Does that help? Above is not arrow. Above is other. Below is arrow. Hopefully I just screwed up. Trying to think of a way to remember. A, B, A, O. A, O, A, B. Okay? Then anytime you start to see like a fraction, you're probably looking at an opening. If it's below, right below that weld symbol, you're looking at an opening. Now, if you start to see some numbers, or slashes, you got it here again. I'm going to come here, 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 here. I don't have room. Here, here. And you see something like this. That's a contour symbol. That means a flat weld. Now, most of the time, 95, we do a flat weld. You want that weld to be flat. You don't want it to be convex. You don't want it to be concave. You want it to be flat. There will be some times, however, where it may ask for, because there's a part sliding through there, that it may ask you to have a concave weld. So that weld does suck in a little bit because there's another part that's going to slide in there. And a flat weld might hit. Okay? Where do you get, this is always a good one, where's the best place to get, what's the best direction of travel to get to concave weld? Huh? Downhill. Yep. Exactly. Alright, so now you've got your contour. So we've got arrow side, other side. Below is arrow, above is other. We've got, if you see a fraction, chances are it's a root opening. Underneath that is going to be the groove angle of the opening of that part. Then you've got your contour symbols. Which way is that weld going to be placed? Is it going to be flat? Is it going to be concave? Is it going to stick out and be a little convex? What is it going to be? Now you also may see, this would be not the best of examples, but you might see a letter. Now we're talking a finish symbol. That might be, needs to be ground, smoothed out, ground, welded flat, ground flush. I don't know, making stuff up now. Okay, this is probably not a great example of a weld that would do that, but you can see if you see a letter, now you're starting to think finish. I'm going to show you one here in a second, a print that it should be in the back of your book, and you'll look at it when I do. And I'm going to talk to you about, this is the part that gets very confusing. Yes, sir, you got a question?
I was just wondering, okay, so if the curve is this way, it means convex?
Just depends on the angle which the weld symbol is on. It just depends on the angle of the weld symbol. That's where the convex and the concave can get kind of confusing, because one's like this, one's like this. Depends where the weld symbol is and how that's going to... I always try to visualize it as the weld. I try to do it that way, and then that seems to help me a little bit. Or it gets real confusing when it's on the other side, and then you got to think of how it would be on the other side. So now we're going to talk length and pitch. Yeah, and I said this earlier, and there's a lot of situations where this is important. Industry wants to save money, and they want to get product out the door as fast as possible. And by them saving money, minimizing distortion, they can do different weld situations that is going to actually allow that part to not get up as hot, to have the strength value that it needs, and still pass the inspection. So a lot of times what they'll do is what they call an intermittent weld. Okay? And an intermittent weld is simply, you're going to weld some, you're going to skip some. You're going to weld some, you're going to skip some. On a, I think they do that, where do they do that? On the like the rock buckets, they weld that off inside.
No, they do that on the side quarters, I don't know what they call it, or the kick panel almost on the bottom.
Where they just weld parts of it.
Yeah, and the black belt's a big one for that.
Yeah.
Because they can't put that in a robot. They gotta do it on a hand.
Okay? So what they'll do is they'll have their part. Here, God dang, that thing just hits bad every time. Here, and they might say 4-8. Okay? Now, I kind of lied to you a little bit. That's also the weld size. On the left side of the weld symbol is where the weld size would be. I said anytime you see a fraction, think of it as groove angle. I lied. The fillet weld will not have a groove angle. I'm sorry, root opening. Yeah, I'm really getting confused. So you'll have, that'll be your weld size to the left of the symbol. The groove angle and the root opening are usually underneath. Okay, so now I've got something that says 4-8. So what that means on my part, if I have my part, I am going to weld 4 inches. So that is 4. And I am going to skip 8 from center to center. So I'm going to weld 4, and that's going to be 8. Okay? From center to center. So when you figure that out, as you weld, and you need to know this, in this case, if it's a 4-8, I'm welding 4, I am skipping 4. I am welding 4, I am skipping 4. Okay? I don't know why they go from center to center. I do know, however, if it said 2-8, it would be a completely different situation. The spacing would be much different. So always remember that the length of the weld is the first, and the pitch, or the skip, is from center to center, and that's the second. Now, how critical is this 4 and 4s? Pretty damn critical. Okay? They are paying attention to that because we're saying this is a weld that's going to be seen. If I weld 3, and then I skip 5, and then weld 5, and then I skip 3, and then, if I don't keep that evenness, you're definitely going to tell. So when I would do this, I would tack, and you'll see pieces, and I'm sure you've seen them, that they will measure out 4 and mark it out first. They'll come by and they'll tack, and then you'll start welding and doing your skips. They measure it out.
Yeah, start to finish.
And it also, because it figures out at the end. Good. I'm not going to say every time, because I'm sure there's been a few times where it didn't, but it was supposed to. Okay, so you really want to make sure you measure those out, you pay attention to that. The other thing when you are welding those is if there's a way you can, I don't care if it's an X, something to make sure before you start putting your hood down and start welding that you know which one you're supposed to weld and which one you're supposed to skip. So when you start looking at a piece, let's say I haven't started welding this yet, okay? And I got a piece of tack here, 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 here. My piece isn't long enough. But now looking at all these tacks, and I get mixed up on the wrong one, and I start welding the wrong section, it's not going to come out at the end. Okay? So you want to make sure, and like I said, my piece wasn't long enough because I would weld, I would skip, I would weld, I would skip, I would weld, I would skip. Oh yeah, it was. Never mind. See, I get confused too.
What would they do, like on the big black belts that they make,
Uh-huh.
they'll weld like a 4-inch or 6-inch section, they'll skip, and they'll weld, they'll skip and weld, and they'll come back, and weld a little bit more, and they'll keep skipping, and they'll come back to like one solid.
One solid. A lot of times they do that for heat.
Well, I know, but how would you draw that up? How would they know that?
I don't know.
Saying what symbol they put in
What
there.
the symbol? Yeah,
Yeah.
I don't know it
Well,
unless they would show like a symbol here, and then maybe have. Sometimes I've seen it where it's another symbol. That wouldn't work.
Cause you've seen a black belt before, haven't you?
Mm-hmm.
Cause they'll do that like one whole side, and they'll go to the other side and do it. When they come back to the other side, then they start the next gap, and then they go all the way around, and they'll just keep going around that thing.
And maybe that's written like in a note or something off to the side. See note after welding the skip around the the base of the whatever wherever you're welding. You come back and you start filling in the gaps. Maybe that would be a note off to the side so the person can look at that and say, okay, after I get done that, I come back to here and I do this again. I do this again. I don't know how that would actually symbol that. Be interested to see. You ought to see if you can get your hands on a print. Just see. I'd be curious to know too, because I don't know for sure.
Yeah, cause I think they do that on the spreader side. I don't know if you've seen like the 18 and 20 footers.
Mm-hmm.
They don't make one solid piece, they do a 3 section. That's because they don't wanna order the piece in that long, so they just go to 3 sections, they weld, they skip and weld, and then come back through and do it.
They butt those together then?
Yeah, they do butt weld.
And then that could be, yeah. I'd be interested to see how they did that too. And that could be somebody who's of experience sitting there that's been told to, this is how you're going to do that. I don't know how that like a newbie coming on there would know. If you can get your hands on a print, see, or I can talk to Gary too and see if I can't get a print to see, because I'd be interested to see how that would work too. So now, in these prints, I know these are very small. This one here is just what we said, a 4/8. It's got an 1/8 inch. Remember, on the left side of the symbol, on a fillet weld, is your bead size. Okay? Now you're going to look at those prints that I drew up, and I may not be right on some of those. I tried my best, but I guarantee I've done these over the years, many times over the years, and I probably screwed them up. And I can tell you, just from experience, that from the side of an engineer having to draw this stuff up and do this stuff, it is very tricky, especially a first print out, to make sure it is done right. It is tough to follow that. The other one can be what they call a skip intermittent, which on one side might weld, this one here is a 2/4, so it's 2 welded here, skip 4. And on the other side it's 2, so it's actually welded all the way across, just opposite sides. Okay, you may see that as well. A lot of stuff. The biggest thing to remember, and I can't stress this enough, that's why I've gone back to it 6 times now, this is 7, hopefully it's in the brain. Below, arrow. Above, other. Weld size is determined to the left of the weld symbol. If you're on a V-groove, a bevel, a groove weld, if you see a fraction below, that's your root opening. Number below that is your groove angle itself. That's it. Oh yeah, never mind. 4-8, if you see something to the right, number dash number, you're talking an intermittent weld. Okay? Now, sometimes things can be completely scatterbrained around. This one here, and this could be how this is done. That's what I was trying to think, but I don't know how it would work in terms of print. This particular symbol says that you're going to do a fillet weld. I think that's I don't know what that number is. I can't read it. 1/4 inch all the way across. Then you're going to do some skips inside, or intermittent welds inside, and then you're going to do another weld across. That's what I was trying to think if there's a way to do it that way, but I don't know if it'd be awfully a lot of symbols. Last parts, weld all around. Okay, if I come up to a square tube sitting on a part, okay, rather than come here, come here, come here, I can just go here, circle this, tell myself it's a fillet weld to the left, 1/8 inch weld, weld that thing all the way around. And I know that's the same thing, just all the way around. Okay? Now, if I had 4 of those parts, I might say something like that. 4 parts all the way around. Rather than label each one every time, same part gets the same thing. Okay? What they're trying to do is minimize the amount of clutter that goes on the print. But for the welder, a lot of times it becomes very confusing as to what you weld. Now, most of the time, over time, you start to get used to it, you start to see that. I would always recommend, before I started on a print type of weld, I would look at the part, I would make sure. It's kind of like reading the directions, right? If I just start building right away, a lot of times I'm going to find myself into a situation where I've just screwed myself. But if I look at this entirety and say, okay, what's got to go first? What do I need to do then? How about after that? Yada, yada, yada. Then I'm going to go ahead and I'm going to prepare myself for the steps to come. Now, the last one is a field weld. You won't see this very often. And I've, to be honest with you, never seen it. What I always use for an example was the St. Louis Arch. When they built the St. Louis Arch, I don't know if you've ever seen that video. It's kind of a cool video, actually. When they built that, they built structures or parts of it in shop. Brought it out to St. Louis to build it as it goes. Well, this is in the 60s, mind you, 50s, 60s, something like that. And as they put that across there, they could not be, what was it? I want to say it was less than, or more than a 3/64 of an inch off. No. Yeah, maybe. From the start to the finish. Now, they didn't have computers and all that stuff to line that stuff up all the time. You know, this was a lot of mathematics going through. So I always use that example for is, as those sections come out and they get set there, if somebody was looking at a print of the St. Louis Arch, this would be a flagged off symbol saying, do not weld this in shop, weld this out of doors. Okay? You won't see that very often. Whew. Any questions? Now, if you take a look, and I thought I had it, I don't. If you take a look on the back, you can start to see what I'm talking about confusing. Okay? This was a print that was drawn up by ATI. I think I've got one from Henderson's in here as well. Henderson?
Yeah.
Now you can take a look at that and see what I mean by, you know, a lot of stuff. You can see all the letters. This would be a part that you would have to be able to build while you're out there. I can see on here, as I weld this, I've got some typicals in the tail, so they're welded the same on the other part. There's a flare bevel, there's a fillet weld, there's a bevel weld. I can see a weld all around symbol. I can see my bill of materials or my parts as they come to me, so I can build that up, and I can kind of go. Now, a newbie looking at something like this, or a welding instructor looking at something like this would be like, oh. But a lot of times, what they have is they have also people who have built fixtures and jigs to set things in to make sure parts are aligning properly. So when you're putting stuff together, you're not running blind.
If it ain't a one-off, 90% of the time it's a big deal.
Right. And that's the most important part to remember. Don't look at this, or my favorite one. Actually, I didn't even think I put the bad one in here. I took it out because it was so bad. Now look at this one here too, and I'm just like, oh, we got a factory there. I'm like, holy shit, there's all kinds of stuff in there. Some gussets throughout there, and there's tag bars, and you know, it's getting pretty precise. The part itself don't look that difficult, but boy, you start looking at all the things inside there, and there's a lot of stuff. But I'll guarantee you, when they set that part up, they've got ways to make sure things are aligned as they tack, and then they can build from there. I would hope that no company would throw you into the lion's den when you first get hired there and say, here, build that. Good luck, we'll see you later. And now that you've done one, you need to do 10 before the end of the night. I would hope that would not happen. But I cannot guarantee anything, because I've seen it firsthand.
When we were at Slow and Final, I helped out at one of the weld lines, and they're building a tailgate study. It's just this plug on the back of the dump body, basically.
Uh-huh.
And they had a newer guy working on them. He built 4 from 7 in the morning, and had to take them to wash at 3 o'clock. But then there's a guy, Jake, that built the same thing. I brought him, the next day I brought him, I think 6 units at 8 o'clock, and at 9 o'clock he was ready for me to take them to wash.
Really?
And
Well, you're gonna find the ways to make it easier. I remember one of my first classes, a kid got hired out of Paladin, and he's really got me a lot of these prints. Probably illegal at that. But he gave me a lot of these, and I asked him, I looked at some of these, and I'm like, how? He goes, once you build the first one, he said, there's tricks to all these that make them so easy. He said, you don't even look at, he goes, I don't even look at the prints anymore. When they come to me, he said, I've got it, I've built them enough where it's just smooth and it's just so. Now, as soon as I say that, you go to like an Excel trailer, because everything is different all the time.
One place is a nightmare looking at blueprints. I go through them as a material handler out there, and there's people out there that can do it, still can't do it.
Well, and in the welder's defense, there wasn't too long where there was a while where they didn't have a lot of prints. There was a lot of just parts, and you just built from parts and you just kept expanding on
That's how
that.
a lot of the projects started out, and they build jigs and everything, and half the time it's not even like the welder's fault, because they all get shipped in from Minnesota or Wisconsin, and half the time it ain't cut right, or it ain't the right part, and they gotta make it work.
Yep. Yeah, so don't become too depressed. But the biggest thing, and I can't stress this enough, because I know at a Henderson, at a Paladin, these companies are going to start to make you take back to paper tests again to make sure you know from the start, you know, the math, the print, the symbols. So when you get to going, now I think at Excel, I don't know if they even use weld symbols yet.
I'm not sure.
To my knowledge,
too much.
they weren't, I know for a while, but they said they were going to start incorporating them in. Their theory is you just weld everything.
Yeah,
Everything that touches your welding, and your welding full. But just be prepared for that stuff. Make sure you know arrow side, other side. Make sure you know groove angles and openings and things like that. So when you do get to those situations, it's not a shock. It might be a little bit of a shaker to get back to where it needs to be. But at least you've heard it, you've gone over it, and you're prepared for it. Now with this sheet here, and then we'll head over there. And if you want to take 5 minutes after that, that's fine. We'll still have break at we'll do break 7:30 tonight, 7:30 to 7:45, and then but then I'll give you a 5-minute smoke break here. If you take a look at this sheet here, okay, what I did is I made these a little bit. I just want to see how well you read the print. And I want to see how well you can make the joint to size. Okay? So what I'm looking for here is I'm checking bead size. You've done all these welds. Every one of them, but maybe the rod. Okay? But I want to make sure that when you laid it in the 1F, or flat position, that you can set up a 1/4 inch weld, probably a little bit bigger than what you've been normally doing, and get to that size, so you know if it says 1/4 inch, you know exactly about what size to be getting. Now, you look at the second one, 3/16, 3/8. On that 3/8 inch weld, I would say, if you're on 35 thousandths wire, you will not get a 3/8 inch weld single pass. You're going to have to triple pass it. If you're on 45 thousandths, you can probably get it, but it's going to be tough. I would still think about triple passing it. Okay, for this particular job. So 3/16, 3/16, that'd be your 3/8. There's an up, there's an overhead. Okay, we've all done those. There is welding 2 rods together. 1/8 inch weld, so it's a small one. I don't care if you pulse this, I don't care what you do to it, but it's a smaller weld on those. Now, I was going to say the C note 2, and we'll get to that page here in a second. Now, obviously, arrow side, other side, is it gonna matter on a T-weld or a lap weld? Not at all, because obviously the other side, I can't tell which side you welded first, which side is arrow side, which side is other side. Unless I would tell you to make a mark on your top piece for arrow side. And I'm not going to do that. So you look at the second page. It says welds need to be 20 inches. I'm not too worried about that. You guys have been doing pretty good at the longer welds. When you do those, just grab pieces out of the barrel. Don't worry about 20 inches and stuff like that. When we were getting sheared steel, is when I was really, and I had the length sheared steel, then I said, okay, got in 28 pieces. It was the first time they'd ever weld on the long. Now we've moved a little farther than that. Okay, so now I want to see skip intermittence on some of these. I want to see a pipe weld, welded halves, 2 halves. Okay, looking good all the way around. Next page, this is the fun one. This one that everybody loves to do. Water box. Okay? You're going to have a water box here. What I will do, how did I do this last time? This print was not drawn by me, by the way. I wanted to get that out first of all. This was one of our students that tried something and it did not work very well. What I want to do with the water box is it's going to have to hold material, hold water, set it up like this, but instead of, if the water leaks or not out of it, I'm going to visually inspect it first. If I see any laps that do not, it's very hard for me to hold pressure to water in this. So it's hard for me to get the water to seep out. Now, obviously, if it pours out, I know you failed. But it's hard for me to hold pressure to this to blow the water. What I used to do is a different one. That was a lot easier for me to see. But this one here, you'll set up the parts. This will be a lock cut on the plasma, so it's going to be sketched out parts. Making sure things fit. Try it out. I wouldn't just start welding stuff off. I would get everything tacked up. Make sure your joints are correct. As I said, this print is not right. And it was drawn in a different program than what I even know. And that program was discontinued. So unless I want to do it, I have to redo the entire thing. And I don't have CAD software anymore. And I need to just get it redone. But you can get the point of it. He didn't mention a few things that he needed to. That's the only part that's wrong. And then you have two more. This one here, there's a trick to this one, so you want to pay attention. These are pass-fail. I'm going to take measurements, tolerance of a 1/16 of an inch, at any point that I measure. They're pass-fail. Before you build this one, it's only 3 parts. So before you build this one, make sure you've got everything set up correctly. Watch your measurements. Think about what happens when maybe steel sits on top of another piece of steel. Okay? when you set that up. The last one is the bathroom bracket. The only thing I'm gonna take out on the bathroom bracket is you do not, repeat, do not need to grind out all the welds on the edge. I wanna see those edge welds. We used to grind those out, however, it takes you 30 minutes to grind those out, and it's more of a hassle. I wanna make sure your part stays square. There's a trick to this one too. You have to think as you start to build. If you do not think right, you will not get welds in there, I promise. So as you construct this, think about, what am I gonna have to build first? What am I gonna have to build second? In order to do this. If you've ever seen this part, this particular part holds the bathroom stalls together. Taking a leak one day, I thought, oh man, that'd be a good little project for kids to go. It's not the same size, it's a little blown up, but. And then you can see the grading scale for the stuff as we go. This is the last of the weld stuff. We still need to talk about torch, and we'll probably do that tomorrow. We're gonna take a test on Thursday on everything we've done so far in the print, the math, and the weld symbols. I wanna give them a day to see this. We're gonna talk about the torch. We're gonna go over the torch safety. It is an exciting video. I'm just kidding, but I have to do it. Okay? And there's a lot of good points into that video that you really like. Oh, I never thought of that. We'll go over the torch. You'll be ready. We've got one dip of air arc torch, and then the rest of the time as well. Other than we got a Tour to XL and Aerotech coming, 21st. So you are set to weld for the rest of the time. When you are ready for that 3/8 inch plate, let me know. I will get them cut up for you. I will probably just run the track torch when we do those, just to make sure. That way if something's screwed up a little bit on the angle, I take credit for it, not you. For instance, when it cuts, if it tracks off just a hair, if we can make it work, that's all I care about. But these are not, like I said, these are not certified weld tests. To let everybody know that this is the way you get your certificate for NICC. Pass this test. But I will say, if you can pass this test, due to the inspections that I give, my inspections are going to be very, very, very close to any certified inspector. Hopefully after this summer, then I can be that certified inspector as well. We wouldn't have the testing facility, but at least I would know exactly what I'm supposed to be looking at. My goal this summer. Learn a little bit. Questions? Rock and roll.
Thank you, thanks for that.
Thanks.
Is it done?
Yeah. Hot metal, that's amazing. Like 2 years ago, I was looking at it. We'll see how this works. Oh, it's broke my phone, I know that. The battery on that thing, too. What was that, 44 hours of that? Oh, no, 14 hours of that. I gotta figure out how to shut it off. Go pocket. Yeah, sorry, deer I shot. Good one. Yeah, should've.